Okay, now we have a new one. This says y equals the square root of x plus 4 minus 1. It's number 2 on our sheet. Now we're going to do the exact same thing we did for number 5, which was the previous video. Now, I know I'm not going in order, but nonetheless, we need to find the domain, range, AH, and K. First thing we do is we find A. Well, A is the number right out here in front, but there's nothing there. That makes it a 1. And we do that because it's multiplication. Now we can find H, and we can find our K. Again, H is going to be right here in this one. It says it's x plus 4, so it means we take the opposite, which makes this minus 4. And then the K we see is minus 1, because it serves at the end. Now, because this one is a square root, I'm going to use different numbers. Okay, so there's our standard little t-chart again. When we did the cube root, we used the first couple perfect cubes. For the square root, I'm going to use the first perfect squares. Now that goes 0, 1, 4, 9, and 16. Now, as you can see on the other chart, which is still kind of visible, I used red. Now I'm using green to show that I'm doing a square root. Again, I use this little idea of x plus h, which in this case is going to be x plus negative 4, which will eventually give me just x minus 4. Again, what that means is I'm taking the possible common starting points of 0, 1, 4, 9, 16, and I'm going to plug them in here. So we take 0 minus that 4, which gives me negative 4. 1 minus 4, which is negative 3. 4 minus 4, which gives us 0. 9 minus 4, which is 5. And then 16 minus 4, which is 12. So essentially what we'll do then is those numbers will plug into our calculators. Well, calculator. Still, we have that trick where we remember that the outputs of those are also common. 0, 1, 2, 3, and 4. So now I'm going to go grab the calculators, take a look and see what we got. I'm going to go straight to the 84 this time, just because I can. It'll save us a little bit of data space. And so we set that there, and hopefully you can see that. Go to my y equals. Clear out the old problem. We don't want that there. So now we just want the square root. X plus 4. Remember, use the arrow key. It's very, very special. You can't see it, but the little circle arrow, push that so it moves outside, so see how the little bar shrinks down? Yeah, that's important. Minus 1. Now, we'd already set the table to ask, but I just want to make sure again, so I come in here, go over ask, hit enter, then I go to the table, and again it gives me these. Ooh, we have our old data, so let's clear that out. Now I get delete, 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 delete. Oh, there you go. So nice blank graph. Now what is I'm going to use the numbers I have right here, those ones we picked. So I put in negative 4, put in negative 3, 0, 5, and if my math is right, we'll get nice integer answers. Oh, look at that, we did. Now, when I look, I remember that we have that little equation out here, ay plus k, which in this case, a is 1, so I get 1 times y, plus negative 1, so really it just tells me y minus 1. And if I double check, why, sure enough, I get that. 0 minus 1 gives me negative 1. Make it better. 1 minus 1 gives me 0. 2 minus 1 would be 1. 3 minus 1 is 2. And 4 minus 1 is 3, giving us our points that we need to graph our graph. How nice. So we'll quit this. We don't need this anymore. So turn it off to save battery. And I'll put it away. Okay. So again, what we need to do is we need to graph this. Well, we have from negative 4 to 12, so we're going to need some. And 0, 3, so let's see if this will fit over here. fit? Oh, just fits. How nice. Now remember, everybody, this is not an art contest, so I'm not going to grade on how perfectly drawn these are, because as you can see, I'm not the best drawer. So we're going to go back 4. 1, 2, 3, 4. But then you go down 1, so that puts me right here. Okay. Go back 3, that puts me at 0. Then 0 happens to be up here at 1. And we start to see a little curve. Got to go all the way out to 5. 1, 2, 3, 4, 5. 5 will put me up here at 2. 6, 7, 8, 9, 10, 11, 12. And 12 finally gets me up here at 3. Alright. So it's kind of stretched out. It's kind of nice. So let's go ahead and graph. Now, notice I start at this point and I'm going to try to connect with a nice, smooth curve, which is not going to be easy because this is really stretched out and it just keeps going. And I kind of made it bad and made it look like it flattens out. There we go. In essence, that's our curve. Not bad. Okay, domain and range. Here, what we're going to look at is, we look at the x's and we look at the y's. What are possible values? Now if we look all the way over here, it kind of cuts off. Now I'm going to grab this and maybe this will show up. I'm going to draw in this little dashed line right here. And I'm doing it in orange. And that happens to be the line x equals -4. Okay. This graph will never go behind that line. It stops right there and is done. That tells me that x is limited. X must be greater than or equal to -4. We can still put -4 and get an answer. Because if you look right here, we did and we got -1. We're going to do the same thing for the y. I'm not going to extend the line quite as far on the graph, but I'm going to draw it right there. And that's the line y equals -1. Okay. So now what we have here, I can define my y is restricted. It must be greater than or equal to -1. So there we go. Now, if you're watching these in order, I'm going to kind of cheat. If you look up here, the domain for this one you can see in the red goes all the way across, so it's all real numbers for both. But the sheet has that on there, so do not worry. The square root was the one I was worried about. So slide that back up. There you go. Again, hopefully this will work just nicely. And if you have any questions, feel free to contact me.